Roots and radicals. Here we go. Some review for you guys. Well, we don't have to be Einstein to know that the square root of 9 is 3. But I want to make a comment because we all know that this is because 3 times 3 is 9. But we also know that -3 times -3 is 9. So we have to have a distinction between three square roots. The first one being when we say the square root of 9 is 3. This is the principal square root, meaning it's the positive. If I say negative square root of 9, then I'm asking you for the negative square root. And of course, if I put a plus or a minus in front of the square root, I'm saying, please give me both. With that said, we are now going to go ahead and go to some definitions. Now, in general, we'll talk about the nth root of x equals y. Well, the number under the radical sign is called the radicand. The symbol itself, as you know, is called the radical. And this number that tells us which root we want is called the index. In general, we can say the nth root of x equals y if y to the n equals x. For example, the cube root of 8 equals 2 because 2 cubed equals 8. With that said, we're going to break down some radicals and have some practice. Now, usually when we break down radicals, we want to be thinking of what I call the perfect squares. The perfect squares being 1 squared, we don't really need, but 2 squared, 3 squared, 4 squared, etc. 36, what do we got? 49, 8 squared, 64, 81, 100, ... We could also say break down cube roots. If we were doing that, we would have to take 2 cubed, 3 cubed, 4 cubed, 5 cubed, and if I wanted to do fourth roots, I'd have to look at perfect fourths. With this said, let's just take some basic examples of breaking down radicals. If I say I want the square root of 50, what you should be saying in your mind is, hey, what perfect square goes into 50? And we would think 25 times 2. We're using the product rule here that radical a times b is the same as radical a times radical b. Now the beauty here is that the square root of 25 is a perfect square, so it can come out of the house as a 5 times radical 2. Now usually when I do these breakdown problems, I put the perfect square first and then the non-perfect square second. This really isn't much different if I do this with radicals. For example, say I meant radicals with variables. 72, a to the 10th, b to the 5th. I'm going to think about this as multiplying 2 different radicals together, and I'm going to put the perfect squares in the first and the non-perfect squares in the second. Well, the perfect square, the largest one that goes into 72, is 36. So it'll be 36 times 2. Now, a to the 10th is a perfect square. Oh, I switched that to a capital A. I didn't mean to do that. Think of that as a little a. It's a perfect square because of a to the 5th times a to the 5th is a to the 10th. Now, b to the 5th is not a perfect square because b squared times b squared is b to the 4th, and b cubed times b cubed is b to the 6th. So I'm going to think of it as b to the 4th times b to the 1st, because the square root of b to the 4th is b squared. This here is my perfect square radical, which is going to come out to 6 a to the 5th b squared. And then that's multiplied by radical 2b. Okay, we're going to stop and I'm going to give you one to try. Moving right along, we could also break down cubes or take cube roots. For example, I could have the cube root of negative 54 a cubed b to the 7th. Now, again, I'm going to make the first radical have an index of 3 and the second one have an index of 3, but I'm going to put the perfect cubes in the first radical. The perfect cube that's the largest that goes into 54 is, I'm thinking to myself, negative 27, because 3 cubed is 27, so negative 3 cubed is negative 27. I'm going to need 27 times 2 to give me 54. The perfect cube that goes into a cubed is actually a cubed because it's already a perfect cube. Now think about this. What's the perfect cube that goes into b to the 7th? The largest one would have to be b to the 6th, because b squared times b squared times b squared is b to the 6th. And we'd multiply a b to the 6th times a b to the 1st to get a b to the 7th. Now, I can take everything here and take it out of the little house and write that as negative 3 a b squared times the cube root of 2b. I'm going to give you one of these to try now. So take another try and we'll go on in a minute. Last thing I want to do is just talk about how we can add radicals. With that said, if I had 2 rad 7 plus 3 rad 7, we can think of these as like terms. It's kind of like having a 2x plus a 3x, where we just add the coefficients. So 2 rad 7 plus 3 rad 7 would just be 5 rad 7. However, it can become a little bit harder if I write that I want to do the square root of 50x minus 12 radical 8x. It doesn't look like these two have like radicands, but I don't know until I break them down. So I'm going to break the 50 into 25 times 2, and the x is going to go in the second radicand because it's not a perfect square, minus 12, and I'm going to do radical 4 times 2x. Well, the square root of 25 is 5, so it's 5 radical 2x minus the square root of 4 is 2, so 12 times 2 is 24 rad 2x. So what is 5 minus 24? I think it's negative 19 rad 2x. I'm going to leave you with 2 more to try, and we'll talk about these tomorrow.